I'm expressing my inner anguish through the majesty of song!
The first kind of operations we're going to look at that can be done on rational expressions are multiplication and division. Recall that when we're simplifying rational expressions, we're looking for common factors in the numerator and denominator so that we can cancel those common factors out. So the first thing I'm going to do with this rational expression is factor each of these four fractions. So you can use whichever method you're familiar with. For the top one, you can use the AC method or the three-bridge method to factor it, which will factor to this. For the denominator of the first term, since my coefficient is 1, I can factor this normally, looking for something that has a product of -5 and a sum of 4, and I can factor it accordingly. For the numerator of the second one, notice that there is a GCF present of x, so I'd first factor that out and then see if I can continue factoring. It will fully factor to this. And in the bottom, there's a common factor, a greatest common factor of 2x. So I'll factor that out, and the term I'm left with is prime. So now that I've factored everything, what I could do mathematically is technically perform this operation of multiplication, and when I multiply two fractions, all of the factors of the numerator will show up in the numerator, and all the factors of the denominator will show up in the denominator, like this. But notice that this hasn't really given me any new information about the question. It's just basically rewriting all the factors I already have present. So when we're simplifying rational expressions, we kind of avoid that step. And what we're going to do is simplify and reduce all in one step in this first question. So this is how you do that. The first thing I'm going to do is look for common factors, any common factor in any of the numerators with any common factors in any of the denominators, and I'm going to cancel those out. So I'm going to look for a 2x minus 3. Well, there's a matching 2x minus 3 in this denominator, so those are going to cancel each other out when I multiply. An x plus 2. I don't see any x plus 2's in the denominator, so I'm going to move on to my next term. The x, I have a matching x down here, so those are going to cancel out. An x minus 2, I have no matched x minus 2, but I do have an x minus 1. So all those terms will cancel out in the multiplication. And you could see it, had we done this, we would have canceled out the same terms. I'm just saving myself some writing rather than rewriting it as a single fraction and then canceling. I'm canceling as I rewrite it as a single fraction. It's going to save me some time. So once I have that, I'll end up with my remaining terms in the numerator and my remaining terms in the denominator. So this will be my final simplified answer. And then I'll just put a box around that. Make sure to box your final answer so you know which expression is representing your final simplified term. Okay. The other type of operation we're going to look at is division. Now recall that when I have an expression like this, when I'm dividing two fractions, I don't really have any rules for that, but division itself just represents multiplication by the reciprocal. So rather than doing this division problem, I'm going to first rewrite it as multiplication by the reciprocal. So notice I've taken the reciprocal of this second fraction. The x cubed plus 8 has gone to the numerator. The x squared plus 2x plus 4 has gone to the denominator. So they've flipped around, reciprocated. And rather than division, I am now multiplying. So it's multiplication by the reciprocal. Then this becomes exactly the same question that we looked at. So I'm going to factor it and then simplify as I go. So I'm going to factor my numerator. It's a difference of 2 cubes. So using my difference of 2 cubes formula, I'll get this. Now, once I've factored that, I'm actually going to make an observation, and I'm going to point it out to you. Notice that this entire second term actually shows up as the denominator of the second fraction. So what that means to me is that I'm not even going to bother factoring that second denominator because I'm going to be able to cancel them later in my question. So I will continue factoring the rest. So I'm going to look at the denominator of the first question, factor this way, and the numerator of the second. Now, the reason I did not factor the denominator of the second one is that I'm now going to be able to cancel it with that factor I observed happens to be the exact same thing. Notice that this entire term is identical to this entire term. I'll also go through my cancellation process similarly to before, canceling any factor of the numerator I can match with a factor of the denominator. And it turns out that all of my denominators have canceled out, and I'm left with just x squared minus 2x plus 4 in the numerator. So that's my final answer, and I will box that.